Okay, so here's what I want you guys to do. Yeah, I'll come get that in a sec. I want you guys to, with your partner, I want you to do just the first problem of each group and see if you remember how that property works. If you don't remember, that's fine. Just move on to the next one.
Yeah. I'm pretty sure.
Wait, really? Oh, yeah. Oh, that's just actually.
Yeah, so just the first one of each group. Just go to each one in each group and see if you remember that property.
I think it's a 0. Oh, this one is.
I like it. I have to socialize with my relatives for like 3 hours.
All right, guys, let's take a look. So 2 squared times 2 to the 3rd, what does that equal? 2 to the 5th. Nice. X to the 4th to the 5th.
It's not 4 to the 5th?
It's not 4 to the 5th. It's not. Because this is like 4 times 8, so it's 32. 4 to the 5th is much bigger. X to the 4th to the 5th. X to the 20th. 2 to the 8th over 2 to the 6th. 2 squared. Alright. 8 to the 0. 1. 2 to the negative 1. 1/2. 4 to the 1/2. Yeah, it's 2 because what does the 1/2 power mean? Square root. Square root. Okay, nice. Good if we remember these. All right, we'll go back and look together examples here. So, one thing that gets asked kind of frequently is, so if we know our answer is 2 to the 5th, you know, do we have to write 32? Yes, you do. But there's some of these that are like what I would call reasonable to calculate. So, you know, 3 to the 4th is 81. I would say that's reasonable. 3 to the 5th, that's like right on the border. You know, you could calculate it, but I wouldn't expect you to have 3 to the 5th memorized. So I'd say kind of like 200 is the line. So, you know, we should know a lot of powers of 2. But powers of 3, I don't know. We don't need to know that many. Some numbers cubed, so like 5 cubed is 125. 6 cubed, this one's kind of on the border. This is 216, but as soon as I get into 7 cubed, I would just leave it as 7 cubed. But that's too big. Let's just leave it. 8 cubed, yeah, we don't need to do all that. So I would say around 200, 250. We don't really need anything much above that. You can just leave it as 7 cubed or 8 cubed. Okay, so x to the 6 times x to the 4th, what is that? X to the 10. What do we get as a result from this one here? A to the 13th, b to the 8. Yeah, this will be the first column. So notice this last year, this is all multiplication, right? This is really a to the 5th times b to the 7th times a to the 8th times b. So those parentheses don't really mean anything. You can just take them away. Okay, what about like x to the 6th plus x to the 4th? Huh? It's just that. Yep. We cannot do anything with this. This is fully simplified. When we're adding, and this is a product property. They have to be being multiplied together. When we're adding them, we're thinking combine like terms. These are not like terms. We would just leave it. But it's easy to get those mixed up. Okay, s to the 4th, t to the 7th, all to the 3rd. What do we get? Oh yeah, they're right on that corner of the card there. Well, this be s to the 12th, t to the 21st. This would be a to the 6th over b to the 15th. Yeah, so we're just distributing the exponent. And that works with, again, multiplication or division. Can I do that in this right here? Can I distribute the exponent? No, we cannot. This does not equal a squared plus b squared. We would have to FOIL that. Yeah, so we can distribute the exponent when it's multiplication or addition, but not, sorry, or division, but not addition or subtraction. All right, so, this is 2 squared. We should, of course, evaluate that before. Okay, this one here, we get x to the 3rd, y to the... Okay, I'm going to add 1 in here. So let's say we have x squared over x to the 10th. One over x to the 8th. So the best way to do this, I would say don't always do the top one minus the bottom. Like we could, 2 minus 10 is negative 8, so we have next x to the negative 8, but then we would move it down anyway. When we do the subtraction, just subtract from wherever the bigger number is. So in this case, 10 is bigger than 2, so do 10 minus 2. 10 is on the bottom, so put the result on the bottom. So let's say we have y to the 5th x cubed over y squared x to the 7th. Turn your partner, what would this be? All right, what would this one be? Y to the 3rd over x to the 4th. Yeah, so I'm doing 5 minus 2, but I'm also doing 7 minus 3. Anything to the 0 power is 1, except for what? 0, yeah, 0 to the 0. This is the indeterminate form. Why is it not just 0? It's not. Indeterminate form means we can't determine it, which means we don't know what it is. It could equal a lot of things. It sort of depends on the context. This is the same thing as 0 divided by 0, or other examples include infinity over infinity, infinity to infinity, etc. We get into this a lot in calculus. It's not nothing, it is something, but we don't know what it is. And it's different. Oh, it depends. So we don't mess around with it. We leave it alone. Okay, so morning.
There was a road blocked off in a car crash.
Oh wow. Okay, so negative exponents. Let's say we have x to the negative 4. What would that equal? 1 over x to the 4th. Yeah, so negative exponent just means move it to the other side of the fraction. So what if I have 1 over x to the negative 3rd? Yeah, this is just x to the 3rd, or x cubed. Yes. So negative exponent means just move it to the other side of the fraction. If it's on the top, move it to the bottom. If it's on the bottom, move it to the top. When we have a full fraction to a negative power, both numbers are going to move to the opposite side of the fraction. So they switch places and the 2 becomes positive. Of course, we could distribute it. It's 9 over 16. So, yeah, that's what the negative exponent means. It's easy to mix up negative exponents and fraction exponents because they're both weird. So it's easy to forget which one's which. So the fraction exponents are the ones that become the roots. Negative means move it to the other side of the fraction. So again, 4 to the 1/2 is square root of 4, which is 2. So 8 to the 2/3. What does this mean?
I don't know how to say. 3 over 2.
Okay.
Well, would the final just be, or I guess it was the cube root of 8 squared, which would be cube root of 64.
Yeah, okay, so we can do cube root of 8 squared, or, which is cube root of 64, or we could do the cube root of 8 squared. It actually doesn't matter which order we do these in. This is an easier order. It's always easier to do the root first, because it makes the number smaller. Like, I don't know the cube root of 64 as fast as I know the cube root of 8. I know the cube root of 8 is 2. I know that 2 squared is 4. So this is the power. This is the root. Either order is fine, though. But I would always suggest doing the root first. Cool. Hopefully this is a review, or at least a reminder of some stuff. Feeling pretty good about these? Good. Of course, what's going to make it difficult is when we start combining these or give you some more difficult ones, et cetera, et cetera. So what we're actually going to do is we're going to look at some examples, and those examples are going to come from your homework. So we're going to start off by doing this. I'm going to give you this. But with your partner, we're going to work through, not these, we're going to skip those. 1 through 17 odd. So we're going to start with those, and then we'll bring it back together. Go over.
Oh, that's not what we have.
Okay, so 1 through 17, work together on this. Let me know if you have questions.
Can you use a calculator?
No, no calculator.
What for stuff like 36 times 36?
You can just write that as.
I would call the first question. First question on our and not on our
This is
Oh, yeah, you're right. Yeah, there's no number 9.
What's that?
Did we do notes on this last class?
No, we did them live today.
Okay, do you have them?
The notes page, yeah, it's right on the corner right there. Yeah, I think you just caught the tail of them.
There's something like pull out.
Yeah, hold on one sec. Okay, so that's that page, and then let's get that, and then get the other page. You're welcome.
Oh, yeah. There's 2 back.
No. No, you shouldn't need a calculator for any of those.
Oh, I can do it.
Yes. 4 through to 16. Oh. Yeah, what I would do is make it 1/16 to 140. This is the negative power. You're right. But that is right. The answer is 1/2. So that would get you 1/2.
Oh, we're huge.
4 through to 16 is 2. Yeah. 4 through to 16 is 2. 27 over 80. 4 through to 1. Yeah.
I don't know what
It's 4 through the top and bottom. 4 through the top and bottom. They said that they're gonna like do it for the first quarter and then take a survey.
Oh, that'll be awesome. I'm pretty sure everyone would be like, no, you can do it. Oh, that's cool. Well, it's really cute, right? That can be so you're going to be oh, that's and then they like wait. I don't know why I'm really too just wait, we can pull the floor. Oh. Oh, gosh. We're just supposed to
Oh, wait, no. The odds up to 17?
All right, let's do a quick checking here. So 1 through 17 odd.
We've done enough.
Okay, questions that we definitely want to talk about as a class. 17. Yes. So 17. Well, it's for the room. We don't have a choice. They're all getting them. Oh, no, I don't. I sure don't. Okay, so we have a root and a power. Again, doing the root first is the easiest. It'll make it smaller. So this is one of those ones where, you might know this root off the top of your head. The 7th root of 128, does anyone know it? It's either a decimal or it's a really small whole number, right? It's 2. Yeah, okay, so it is 2, but 2 is a pretty good guess. If you think of, okay, it's because I could do maybe it's 2, so I would go through powers of 2. This is my thought process here. So 2, 4, 8, 16, 32, 64. There it is. Okay, it's 128. it's easy to check too. If I start to do that with 3, it gets out of hand pretty quick. You know, squared, so times 3, and now I'm already, that times 3 is like 123, right?
Yeah.
So that's like already too big.
And that's
So if I'm giving you a 7th root question, either it's doable and the answer is going to be like something reasonable, or it's just not a perfect 7th, and then you can't do it. So either it's going to be easy, straightforward, or you just can't do it, and that's the point, is not to do it. So if it was like, you know, 123 instead or something like that, I would say my answer would just be, okay, well, this is 1 over like 123 to the 4th sevenths or something like that. That's the only answer I could give, which is actually even easier if you think about it. But in this case here, it is -2. Odd roots have an odd answer. So like the cube root of -8 is -2. And then 2 to the 4th. 2 to the 4th. 2 to the 4th. This is 1 over 16. So do the root first. Root, then power. 128 to the 4th power is ridiculous. Don't want to do that. Do the 7th root first. Notice that -2 to the 4th power is going to be positive. Other questions that we want to go over? Number 1, yes. So number 1, here's what I would want to do. I would say negative power moves it to the bottom. And then it's a negative number to the 4th power. So my result is going to be, what would we say, even or odd? Or not even or odd, positive or negative. Yeah, it's going to be positive. So the simplest version of this, 1 over 6 to the 4th. I don't need to know 6 to the 4th. It's 1296 if you're interested, but I don't need to know that. So then, spoiler alert for number 2, this would be -1 over 6 to the 4th, because the negative is outside the parentheses. The order of operations is do exponents first. Other questions from 1 through 17? 13. So 13, we have a negative power. So I move that down to the other side of the fraction. And then 16 to the 1/4 power. That means the 4th root of 16. What is the 4th root of 16? 4th root of 16 is 2. This would be 1 over 2. Other questions? 14? Yeah, we can look at 14. With 14, what I would do here is change everything to 3s. So this is 3 to the 7th. 9 is 3 squared. 27 is 3. Three cubes? Yeah, it is. 27 is 3 cubes. Okay, so we see what I've done here. Questions so far? I just changed everything to 3. So 9 is 3 squared, 27 is 3 cubes. Now I can use my power properties, and we all have the same base. So it's 3 to the 7th times 3 to the 8th. This is 3 to the 3rd to the 6th to the 1/2. Kind of got me thinking about that. with that Will.I.am song. It's like, hey, you know that song? I don't know any of the words, obviously, but multiply the power. So 3 times 6 times 1/2 is 9. Add these powers. Then subtract. What?
For the first 3, like at the bottom, is this like 3 to the third, and like what the number is?
Yeah, 3 to the third to the 6th. Now that sounds stuck in my head.
Oh,
Okay.
the 1/2 cube, is that on the bottom? Why are you doing?
No, so square root is a 1/2 power.
Oh, okay.
Yeah.
Oh, 27 to the third.
Yeah. Does that one make sense? What is there? Other questions from the odds? What?
I was gonna ask, if so this is like homework, is there gonna be like a key online? You wanna like do
Yeah. 15, yeah. So again, 15, if we have a root and a power, we should always do the root first. Cube root of 216. 6. Yeah. If you don't know this one, here's some logical ways that we can figure it out. First of all, it's an even number, so the cube root must also be even. The digits add to 3, or to a number that's divisible by 3, which means it's a multiple of 3, and it's even. So 6 is a pretty good candidate. We always test it out. 36 times 6. Yeah, it is 216. So 6 squared, 36. Okay, I'm going to go through and just get the other ones, the other odds, just so you can check your answers and see. So number 3 is 225. Number 5, I would just say is 8 cubed over 7 cubed. 7 is 9. This one here, 11 is kind of crazy. I would say this is root 2 times root 12. 12 simplifies to 2 root 3. This multiplies to 2 root 6. That's all the odds. Questions on any of those? Okay, cool. So on this same paper, do the rest of the odds. Do all the problems? No, which ones? The odds.
Oh.
Yeah, the rest of the paper, it's the odds. So that's numbered not divisible by 2. Los impares. Huh? Yes. The homework's going to be finished, whatever you don't finish. Oh no, it's not Will.I.am. It's a song. It's Bang Bang by Nicki Minaj, Jesse J.
How is that?
Sir?
Oh yeah, it's the one. You know, that's one that's this one.
So, yeah.
Are you in drama? Oh,
Oh, I don't know why that would happen. That's my answer. What underscore?
Yeah, I have the water.
What are you
The
guys
R underscore. Simplified. The R is number.
Because if they were, I am like mad.
I don't know what I did either.
I'm pretty sure this was
I'll figure out this stuff.
we don't get to know.
I just want to know.
You think we know it's wait, that's is this what you got?
I got everything like that except the R. Well, that's the same. Yes. And that is. But that is what I got. Can a variable be inspired by some?
Yeah.
Wait, what? Can a variable be inspired by one? But
That's a G. Alright. Talking myself out.
depending on what person's asking. But I didn't know.
Wow.
No, I used to like. Alright.
So,
Wait, so
That's
right.
I need to schedule a meeting.
Katie.
Oh.
No, you're gonna get married.
Wait, it's actually in the
No, I said it's that's a good thing.
oh my god.
I thought it was I think that's
Oh my god. Oh, the age
This is a really stupid.
Yeah.
So when you take just I mean literally just a packet. Is that what you got? Yes. Okay, that is what I got by the way. So if I have to repeat that, I don't think so. Okay, so I'm about to hit.
Yeah.
That's smart.
Okay. Yeah. So like, is this what? Don't think.
Are you kidding me?
What I did is I just did this. I did the -4 + 2 is 1.
I want to make yours.
Oh god, this one has brackets.
That is
So that's almost.
Like I'm pretty sure this shows it well enough that whatever that is. That's what I'm saying. Do you want the physical login number? I didn't even know that you could there.
Wait, is that what you mean? Is that from that?
Just want to, I would do this part first. So why?
So, is it like hard for this, or does it just end up being part of the paper?
It doesn't appear.
Oh, it does? Oh, okay. Well, that's what I thought, but then I also thought that it was wrong. Really?
I'll start writing the wrong answer.
No, 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 I don't want that. No,
I will talk to someone. I will use
Okay,
it.
they could go wrong.
no.
So, because they're distribute this first, so then it becomes 1 negatively.
I'm just
So then you turn that down.
Yeah.
This is still here.
Yeah.
So instead of doing 1 over 1 of 8, this.
Hey, Brian, did I do well on my test?
And then,
I don't know.
well, obviously.
I've graded everyone's standards 1 through first question. So then everyone's, you get 4 grades for your test anyway, so it's not say I think you do well.
I didn't even know we still do that. Does he just want us to plug in?
We'll see.
It's gonna be like
Yeah, I'm literally about to grade the last question, so.
No, I just plugged it in. Oh, should be. You just know over grades and stuff? What do you mean? How did I figure out that it was 4? Because I just did 2 times 3 and that's 16. 4 times 4 times 4 is 4. 4 times 4 is 16. And if you, I don't know if it's that, but I just know that if it's 16 times 16, so the 6 and the 6 will be 6, and it's like 4. Probably.
Really struggling.
You're welcome. that's it. Yeah. Okay. Don't. Oh, you've done this one. Don't look.
Oh, wow.
Spoil the answer for you. It's called science. Pretty silly. How? How well? Don't listen to me. I just plugged in matters. Yeah. Smart. Thank you. Okay. We have like a more creative.
Oh, no. Is that like you rub on from
It does. This one is super easy. What?
Not just like a